Hello my dear students, in this video we are going to study involution law. Involution law states that when a complemented variable is complemented again, then we are going to get the same variable. Here let us write x double complement is equal to x. So that is the meaning of this definition. Here we can draw the same in the form of logic gate. So we will write first x naught. Here if I input x, we are going to get x naught. Again if it is combined with the not operator, then it is going to give us x double bar, which is equal to x again, right? So let us prove this one algebraically. Let us write the proof. If x is 0, then x bar is equal to what? It is 1, right? And here we will write x double bar is equal to, here x bar is what? X bar is 1. So this x bar is 1, this complement is as it is. So here once a complement gives me what? It is 0. 0 is what here? 0 is x. So it is equal to RHS. Now in a similar way, if x is equal to 1, then x complement is equal to what? If it is what? Then the result of the not is 0, correct? And here we will write x double complement is equal to, here x complement is what? 0. X complement is 0. So this complement as it is. So 0 complement gives me what? 1. 1 is what? 1 is x. So which is RHS, that is the right hand side, right? Now let us draw the truth table for the same. So here we are going to write the variable x whose values are either 0 or 1. Next we will write x complement. If it is 0, then the complement is 1. If the input is 1, then the complement is 0. Now we are going to double complement this. So we need to consider this particular column and complement it once again. So here if it is 1, then the result is 0, and if it is 0, then the result is 1. And here we can compare both of these two columns. Hence we will say this involution law proves LHS is equal to RHS. So here x double bar is equal to x. Okay. Now let us move on to the next law, that is complementarity law. Yes. So this complementarity law states that x or x bar is equal to 1, and next is b. Here we write x and x bar is equal to 0. So let us draw the logic gate. So here x or operator, and here we are going to write x complement. We can take the same and here we will make it not, right? Yes. So it is going to combine with OR gate. So OR, and this results in what? It is 1. So here we are going to input x, but here we are going to get x complement. X or x complement gives me 1. Now similarly we are going to write b. Here we will write x and x bar. So x we are going to take, and we will take the same here, and we will take not. If it is x, here it will be x bar. So it will be combined with the AND gate, and result is what here? It is 0, right? Yes. Let us have the proof of A. First we will write if x is equal to 0, then we will write LHS is equal to, that is x or x bar is equal to, here we will write substitute the value of x is equal to 0. Here x is 0 and x is 0 complement. Here we will write 0 or 0 complement gives me 1. Here 0 or 1 gives me 1. So 1 is what? 1 is RHS. So that is right hand side. Now let us write if x is equal to 1, then LHS is equal to x or x bar, and here we will substitute the value of x as 1 plus 1 bar. Here we will write 1 or 1 bar is what? 0. So 1 or 0 gives me 1 again. So 1 is what? It is the right hand side. Hence the proof. So let us draw the truth table for this law. Here we are going to write x bar, x or x bar, right? Yes. So whether it is true or not, we are going to see. The value of x would be either 0 or 1. X complementation gives me what? If it is 0, then it is 1. If it is 1, then the result is 0. Here we are going to OR between these two columns. Correct? True is true and false is false. Here in this case OR, and here we have got true false is also true. True false is also true. Right? Here in this column you can see both the values of these two rows is true. It is always true. Any logical statement which is always true is called as tautology. Yes. If it is false, then it is fallacy. Right? Yes. Let us move on to the proof of B. We will write proof x and x bar is equal to 0. We need to prove, right? Yes. If x is equal to 0, then we will write x and x, that is LHS is equal to x and x bar. Here x value is what? 0 and x bar is 0 bar. Here we will write 0 and 0 complement gives me 1. So in case of adding, true is true, otherwise it is what? False. So here RH is what? It is 0, right? So hence the proof. Now let us substitute the next value of x, that is 1. Then we will write LHS is equal to x and x1. So here x is 1 and x is 1 and complement. Here we will write 1 and 1 complement is 0. So true is true, otherwise it is false. So here we are going to get 0. So 0 is what? 0 is right hand side. Hence the proof. Now we are going to write the truth table for the same. Here we write x, x bar, x and x bar. So x value will be 0 and 1. If it is 0, the complement of x gives me 1. If it is 1, the complement of 1 gives me 0. Right? And next we are going to perform ANDing between these two columns. ANDing gives me true is true, otherwise it is false. So here you can see false, true is false, true, false is also false. So here in this case, the third column you can see all the values of this particular column is 0. Hence it is called as fallacy. Fallacy means what? It is any logical statements that always results in the false value is called as fallacy. Okay? Yes. Now let us move on to commutative law. Yes. So this law states that x or y is equal to y or x. Correct? Next, b, x and y is equal to y and x. And let us draw the logic gate for both of these two expressions. So here we will write x or y. Correct? Yes. So which is equal to y or x. Correct? Yes. Next, this is a and next we write b. That is x and y. So how do you write and? Something like this. Right? So and here which is equal to y and x. Yes. Next we are going to prove the first expression. Let us write proof. Let us take if x is equal to 0, then we will take LHS is equal to x or y. Correct? Yes. So here we will write x value is what? X value is 0 plus y. Correct? So 0 plus y as per properties of zeros and 1. What it gives? It gives us y. Right? Yes. Let us take RHS now. RHS is equal to, that is y or x. Let us substitute the value of x. X is 0. Y or 0 is what? Y only. Here you can see LHS is also y, RHS is also y. So therefore we can say LHS is equal to RHS. So hence the proof. Now let us substitute x is equal to 1. If x is equal to 1, then we write LHS is equal to x or y. So here the value of x is what? 1 plus y. So as per the properties of zeros and 1 plus y, 1 or y was giving what? It is 1. Correct? Next we will write RHS. So that is right hand side. So that is y or x. Here y value as it is, x value is 1. So that is as per properties of 0, then 1 or x is what? 1. So similarly y or 1 is 1. So here you can see both LHS is equal to 1 and RHS is equal to 1. Hence LHS is equal to RHS. Now let us prove the same using truth table. Here we will write two columns, that is x and y, because expression consisting of two variables, and here we are going to get 4 rows. Let us perform first x or y and then y or x. So what is the value of x? For the first time it is 0, 0, 0, 1, 1, 0, 1, 1. So when we convert this binary into decimal, so it is written in a increasing order. 0, 0, 1, if it is converted into decimal, it gives me 1. 1, 0 represent 2. 1, 1 represent 3. It is written in a increasing order. Right? So next we need to perform ORing. ORing gives me what? False, false is false, otherwise it is true. Correct? In the same way, y or x, false, false is false, sorry, otherwise it is true only. Yes, here you can see both of these two columns, that is x or y is equal to y or x, because all the values are same in both of these two columns. Hence the proof. Now let us move on to B. Write B here, x and y is equal to y and x. Let us write if x is equal to 0, then we will take LHS is equal to x or y. So here x value is what? It is 0 and y. So 0 and x gives me, as per properties of zeros and 1, what it gives? It gives me 0 only. Right? Next we will take RHS. So RHS is equal to what? Y and x. So here y and x is what? 0. So y into 0 gives me what? 0 only. So LHS is also 0, RHS is also 0. So therefore we can say LHS is equal to RHS. So hence the proof. Now let us substitute. If x is equal to 1, then LHS is equal to x and y. So here we are going to substitute the value of x is equal to 1 into y. So as per the properties of zeros and 1 and x gives me x. Similarly 1 and y gives me y. So let us write RHS right hand side. So this gives me y and x. Let us substitute the value of x as 1. Now y and 1 gives me what? Y. Here you can see LHS is y, RHS is also y. Hence we will say LHS is equal to RHS. Hence the proof. Now let us write the truth table for the same. Here we will write x, y, and we will perform x and y, and then y and x. X value is 0, y value is 0. 0, 1, 1, 0, 1, 1. Because we have got two variables, 4 rows, and we are going to write them in a ascending order or increasing order. 0 0 when we convert it into decimal, it gives me 0. 0 1 when we convert this one into decimal, it gives me 1. 1 0 represent 2. 1 1 represent 3. We have written in a increasing order. Next, we are going to perform ANDing between these two columns. True is true, otherwise it is false. Correct? X and Y. Next one we need to perform Y and X. Y and X. So it is true and true is true, otherwise it is false. You can compare both of these two columns, that is X and Y is equal to Y and X. Why? Because values of both the columns are same. Hence the proof. That's all in this video. Thank you very much for watching this video. We will see you in the next video.